my name's Erica Carlson. I'm a theoretical physicist at the Purdue Quantum Science and Engineering Institute. Welcome to Quantum Connections, where we have interesting conversations with people working on all things quantum. Our guest today is Dr. Laura Greene. Dr. Greene is a fellow of the National Academy of Sciences and a fellow of the American Academy of Arts and Sciences. She is the chief scientist at the National High Magnetic Field Lab, and she was recently appointed to the President's Council of Advisors on Science and Technology. She's also a past president of the American Physical Society. I could go on, but she has a long list of credentials and awards. Thank you so much for joining us today, Dr. Greene.
It's a pleasure to be here. Thank you for having me.
So first of all, congratulations on your appointment to the President's Council of Advisors on Science and Technology. Could you tell us a little bit about what that means to you?
Well, it meant a huge amount to me. In fact, that it's a way that I can serve my country, and maybe with in a way that I can do it best. I'm not going to be. I've never had the courage to join the armed forces. I respect everyone who will serve our country, and this is giving me that chance. Also, with my background, and I like saying it's not always what you know, it's who you know. I've been in contact with many, many people across science and technology and sociology, and I think I can bring a unique perspective to help the nation in its pursuit of innovation and competitiveness.
Very exciting. So, Dr. Greene, we're also interested in what originally got you interested in becoming a scientist.
I have a standard answer for that. I was born that way. I was hardwired that way. In my earliest years, I remember reaching very high up in the kitchen sink, wondering why. So I was really little. Why water was wet and was it made out of little chunks? And you know, I was always taking things apart, and I just couldn't get enough of it. And I was also raised on things like Mr. Wizard. It just was everything. But I didn't start out doing condensed matter physics or superconductivity. You start out by looking at the stars, and that kind of helps you get into it. And then the technology of Sputnik and Echo, I was alive then, and it was just very, very exciting.
Now, you started this new position at the National High Magnetic Field Lab as their chief scientist about 6 years ago. What brought you to Florida State?
The Magnet Lab. No, Florida State is a great university, but it was really the Magnet Lab. When I felt it was time for a change, it's very invigorating. And when I looked at all the options I had, I decided that the Magnet Lab was a really fantastic option because of the breadth and the depth. It's core funding is from the National Science Foundation, which is unlike most of the labs we know about our DOE labs or Commerce or DOD. So we really have, as one of our requirements, is fundamental research has to be a good part of our work, and education has to be and education research. And besides that, we are primarily a user facility, and we have 7 user facilities, and I don't just look at us as the best magnet lab in the world, but the best national laboratory in the world, because we do everything from sustainability, the effect of sun on plastic bags, where we could measure spectrometry down to 1 electron of mass, early detection of plaque amyloids, and also the kind of work that I do, which is looking at quantum materials and novel correlated electron materials.
Very exciting. Now, of all the great research going on in quantum materials in your lab right now, could you tell us what you're most excited about?
Oh, that's hard to say. It's hard to choose your favorite baby, but I would say that we published a paper last year that was all about a new pairing mechanism for a heavy fermion superconductor. So one of the things that I study is something called unconventional superconductors. Superconductors were discovered in 1911, and it took 50 years to figure out how they worked. Now there's all these other kinds of superconductors that aren't conventional. They don't work in the way that the old ones work. And they're all very, very different. Each one is a whole universe of excitement. And so all superconductors to date have to be cooled. And when they cool down, the electrons go into pairs so they can fall into the electrons pair up. I can go into more detail, but how they pair is what's different in these other materials. And we've discovered a novel magnetic pairing mechanism for this heavy fermion superconductor.
Very interesting. Now, I'm also curious to ask you why it is that people are so excited about all things quantum right now, and especially, with your work being in such a national prominence. Why do you think people are so excited about all things quantum right now? And I'd be interested to hear from you. Why is the United States so interested in all things quantum right now, especially say with the National Quantum Initiative?
Well, there's quantum is all around us. That's what we do. Whether it's, most of these quantum materials in our cell phone didn't even exist 20 years ago. Our entire economy is based on it. When I got into superconductivity, I left far infrared physics to get into superconductivity. And what I found is I never thought I'd stay in one field for so long. There are so many onion skins, and every time you learn more, something else gets peeled back. And so one of the things that people have said is that, when quantum mechanics started in the 20s, or some people even say before that, depending how you measure it, that was the whole idea, was controlling and understanding the quantum so we could, for our cell phones, for example. Now we having the ability to quantum as a wave, right? Not just control the size and the energy of the quantum, but also the phase. Gives you a whole new aspect of whether you're doing, any kind of understanding of uh, quantum learning, or the other one is everyone's saying AI, artificial intelligence. All this stuff is moving along very, very quickly. Also, it's important in terms of national defense for cybersecurity. If other countries are going in those directions, we have to too. And that's been in the news a lot lately. So it's important both for the amazing applications that are discussed, the whole quantum computing business, but it's just sheerly gorgeous to study. It's really beautiful.
And now I'm curious, what do you think are some of the most important things then for the country to do right now to stay on top of this quantum revolution?
I think they're doing a lot of it. There are initiatives going on right now. I think also one of the things that Biden wrote in his letter to PCAST was to worry about bringing in the rest of the country. So can we have innovation hubs that will be not just on the coast, but also other places in the United States, and make them hotbeds for innovation and competitiveness? So in the US, we may not have the money that other countries do, like China, to throw at it, or we may not have the personnel resources, but there are certain things that American innovation does that is really exciting. And so if you read books like Jumpstarting America, it really signifies, and that what we have to do is let people uh, do some very fundamental research, and also learn how to hand it off and how that's done. So those are the kind of directions that we're really worrying about. In fact, I would like to see our national laboratories work across jurisdictions a little better. Why shouldn't national labs be only funded by one agency? And there's a little bit of that starting now. I'd like to see more of it. And I'd like to see students more involved in our national laboratories, and also international collaborations, because science has to be an international endeavor.
Absolutely, one of the great privileges I think of being a scientist is that we are in an international community, and so I have to confess that most of the times that I've seen Dr. Greene in person, we've been in another country at a conference, and so she is quite the world traveler. So thank you so much for taking time out of your very busy schedule in order to talk with us today.
Thank you for having me.